Understand that by similarity, side ratios in right triangles are properties of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. So we can see that sine is a ratio of opposite over hypotenuse. See that cosine is the ratio of adjacent over hypotenuse. I see that tangent is the ratio of opposite over adjacent. And we know that we use SOHCAHTOA as sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. All right, label the side that is opposite and adjacent to J. Label the hypotenuse. So, put my theta on J. Here, I know the opposite is straight across from angle J. Adjacent, I always know that the adjacent angle has the letter J in it, which is the angle that is our theta. And we know that adjacent is right next to it as well. We also know that JD is right next to J, but we also know it's across from the 90-degree angle, which makes it the hypotenuse. Alright, let me look down here at the bottom. It says sine of angle A. Alright, so we look here, we got opposite over hypotenuse, which is 4 over square root of 17, which is 0.97. And then we look at cosine of A, which is B adjacent over hypotenuse, which is 1 over square root of 17, which is 0.24. Then we got tangent of A. Tangent of A, which is opposite over adjacent, which is 4 over 1, which is just 4. Alright. Then we got sine of B, opposite over hypotenuse, which is 1 over square root of 17, which is 0.24, which is the same thing as cosine of A. And then we got cosine of B, which is adjacent, which has the letter B in it as well, over hypotenuse, which is 4 over square root of 17, which is 0.97, which is the same thing as the sine of A, because they are complementary angles. Alright, we know that the sine of one complementary angle is the same as the cosine of the other complementary angle. And we know that complementary angles make 90 degrees. So we look at the tangent of B. Tangent of B here is opposite over adjacent. So it's 1 over 4, which is 0.25. Alright, explain and use the relationship between the sine and cosine of complementary angles. I can explain the relationship between the sine and cosine of complementary angles is that they are the same measure because the opposite of one angle is the same as the adjacent of the other complementary angle. And they both have the hypotenuse as the denominator. If a right triangle has an acute angle that measures 50 degrees, what is the sine of the other acute angle? So we got sine of 90 minus 50, which is sine of 40, which equals 0.64. If the sine of 3/5, if the sine of A is 3/5, then the cosine of 90 minus A is also 3/5, because we know that the sine of one complementary angle is the same as the cosine of the other complementary angle. Use trigonometric ratios and the Pythagorean theorem to solve right triangles and applied problems. So it says I can use sine, cosine, and tangent to find the sides of right triangles. Yes. We just showed that. I can use the inverse of sine and cosine and tangent to find the angles in right triangle. We're about to do that on the next slide. I can use the Pythagorean theorem to find the side in a right triangle. We've done that to find the missing sides. I can use these methods to solve applied problems. Alright, so we look at this page right here. We're going to be solving triangles. So we set it up. We look at this angle as our theta. And we look opposite. And we have our hypotenuse. So we can set up a trig function to find the missing side length. So I got sine of 35 over 1 equals opposite over hypotenuse. So I can cross multiply here, and I get sine of 35x equals 11. I divide by sine of 35, 11 divided by sine of 35, and that gives me x equals 15.56. Our next problem, I have theta is angle 63, which gives me adjacent over hypotenuse, which is cosine of 63 equals adjacent over hypotenuse. So I got cosine of 63 times 5, and then x times 1. Cosine of 63 times 5 gave me x equals 2.667. Alright, my next problem, I look at theta, which is x, so we're going to try to find x. So I do opposite over adjacent, which is 9 over 2. So I have tangent of x equals 9 over 2. I have to find the inverse in order to find the angle. So hit shift tangent, 9 over 2, which gives me 77.47 degrees. A 10-foot ladder leans against the wall at an angle of 35 degrees. How far from the wall is the base of the ladder? Draw a picture, completely label the necessary information. So I have a 10-foot ladder right here leaning up against the wall at a 35-degree angle. I know the ladder is 10 foot, and so I have opposite over hypotenuse. So I can set up my trig function. Sine of 35 equals x over 10, cross multiply. Sine of 35 times 10 equals x. Sine of 35 times 10 is 5.74 feet. A kite is flying 70 feet above the ground and is attached to a string tied to a stake on the ground. The angle of elevation formed by the string and the ground is 40 degrees. So I have a kite that's just 70 feet off the ground. Here's its string coming down. It's 40 degrees angle up of elevation. Find the length of the string. So that is opposite over hypotenuse. So it's going to be sine of 40 equals 70 over x. Cross multiply. I get sine of 40 times x equals 70. Divide by sine of 40, x equals 108.9 feet. Alright, make your cheat notes for your test here.